Yes, so the question is, having the following probabilities, having the following probabilities. You have to arrange these probabilities in ascending order. In ascending order. Okay. So how we can arrange these probabilities in the ascending order? Now the probabilities that they have given, the first is yes. Yes, arrange the following probabilities in the ascending order. The probabilities they have given, it is the first is the probability of A union B, then the probability of A, probability of A plus probability of B, and the last is the probability of A intersection B. Yes, so can you tell me what will be my first probability? Now we have to arrange this probability in the ascending order. Okay, so what will be my solution here? What is the solution? Now first understand. Suppose let's understand this in this bar Venn diagram. This is my A event, right? Okay, this is my B event, and this will be my sample space, right? And this is the A intersection B. And in this case, you can clearly say that my A intersection is what? It is actually subset of this A, right? I can say that A intersection B is the subset of A. Then which probability is smaller then? Definitely this probability will be smaller, right? The intersection probability will be smaller. So I can say that the probability of A intersection B is what less than equals to probability of A. Okay? So this is the one condition I get. Now again, I also know that the one thing that is, now if you saying this A, okay, this A set. Now this A set is also what subset of what? Union, right? A union B. A union B means what? Whole set, and A means just a set A. So I know that the A is subset of what? A is subset of A union B. So definitely my probability of A what? It will be less than equals to probability of A union B. Okay, that is the one point. So this is my first equation. This is my second equation. Okay. Now again I know the one thing. I have one Bully's equation. We have seen this Bully's equation, right? So what is Bully's equation? So Bully's equation is nothing but it is probability of A union B. It is always less than equals to what? Probability of A plus probability of B. Okay. Probability of A union B is always less than equals to probability of A plus probability of B. This will be my third equation. And from this all these three equations, what I am getting there? Yes, what will be my point? Now we have to arrange this in the ascending order, right? So first will be this probability, first will be this, second is this, third is this, and fourth is this. Simple. So we can write my ascending order of this particular equation will be what? It is probability of A intersection B less than equals to probability of A less than equals to probability of A union B less than equals to probability of A plus probability of B. Okay, so that is my ascending order. How we can arrange the ascending, right? That probabilities in the ascending order. Okay, now write down the second question. let A and B be the two events. Okay, I have the second question. Let A and B, right? These are my two events defined on the sample space. This is defined on sample space. This is defined on sample space omega. Okay, this is defined on sample space omega such that such that probability of A equals probability of A equals to 3 by 4 and probability of B is equals to 5 by 8. Okay, so these are the two probabilities they have given. Have they want to show that we have to show that we have to show that what 3 by 8 is less than equals to probability of A intersection B less than equals to 5 by 8. Okay, we have to show this. Right, the given things are this, and from this we have to show this. So how we can do that then? Yes, how we can solve this? Yes. Now here step by step you have to go for this example to understand what it. Now here first understand you already know that intersection is the subset of these, right? Again I am if I am considering the Venn diagram, you know that how it is. Suppose I have two states, right? A, this is my one particular event. The another event is there, that is the B event. Okay, so these two event I have. Then the 100% this A intersection will be what? This will be my subset of B, right? Yes, I can write this. So what I can write? What I can write? I can write that this A intersection is subset of B. Okay, so A intersection B is my subset of B. Okay, now from this I will simply get probability of A intersection V is what is less than equals to probability of B, right or not? Right. Right. So probability of A intersection V will be less than equals to probability of B. So that is probability of B is what? We don't know probability of A intersection B yet, right? I think we need not to find that probability of A intersection. But yes, what is probability of B? It is 5 by 8. Okay, probability of B is 5 by 8. Now again we have one theorem. Okay, it is actually theorem 9. We already have seen this theorem. So what is that theorem? We have seen one condition. What is our condition? Addition principle. Okay, and from that addition principle we have a theorem, that is probability of A intersection B is always greater than equals to probability of A plus probability of B minus 1. Okay, it is greater than equals to probability of A plus probability of B minus 1. And from this we will get probability of A intersection B. Just substitute the value. Right, what is probability of A? It is K by 4. Probability of B is what? It is 5 by 8 minus 1. And this will implies probability of A intersection B is greater than equals to what? Yes, multiply this by 2. So this will be 6 by 8, right? So this is 6 by 8 plus 5 by 8. I think it is 11 by 8 minus 1. And from this I will get what? What I will get? Probability of A intersection B greater than equals to what? 3 by 8, right? Okay, so this is the first condition which I get already. That means the half of the proof we have proved now. Right, this part we have proved. It is greater than equals to 3 by 8. Now we have to prove this. How we can prove that? How we can prove that? I think this is also we have proved, right? Here only. That is probability of A intersection is less than equals to probability of A. So this is my first point. This is the first part of the proof, and this is the second part of it. And from these two equations, I will get what? I will get what? So the from first and second, okay, from first and second, what I will get? 3 by 8 is less than equals to probability of A intersection B less than equals to 5 by 8. Okay, so this is how we can prove this particular step. Okay, yes, now another one things are there. Yes, now only two examples are remaining that we will take and we'll stop our lecture. Okay, right. So, okay, now the next is simple example. Right, again they have given me the two events that is A and B. Two events I have. If I know the sample space omega, if I know the sample space omega, we have to just okay, we have to just identify the things that is whether the following right following statements are true or false. Okay, we have to just state true or false. Correct, sir. एवढे एक लेक्चर रेकॉर्ड केलेले नाही लेक्चरचे 10,000 आहे ना बाकीच्या मग युट्यूबवर okay. Right, so we have to prove whether all statement are true or false. First, they have given me probability of A equals to P of A equals to 0.8, P of B is equals to 0.7, probability of A intersection B equals to 0.8. Okay, this is the first statement, and second is probability of A is 0.8, probability of B is 0.7, and probability of A intersection B it is 0.3. And I have to tell whether these statements are true or false. Yes, so can anyone tell me about the first statement? It is true or not? Yes. Now we have already seen, right? If we have two sets A and B, right? This is the intersection and this is A. Then the property is the intersection will always what? Intersection will what? Intersection is always yes and what? This property we have. Okay, I will just show you. intersection is always smaller than the probability of A and B because this is subset. Okay, I am talking about the intersection. So this intersection A intersection B is always less than equals to B, that is, it is subset of B, and also this intersection, it is subset of A, right? Because this is the smaller set. It is subset of A and it is subset of B also. That means what? Probability of A intersection B is always less than equals to probability of B, or it must be less than equals to A. Then tell me the first statement is true or false. So it will be true or false. It will be false, right? It will be false. Why it is false? Because here the intersection is what? Intersection is greater than this probability of B. Okay. Here we can write that here probability of A intersection B is greater than equals to, or it is simply greater than probability of B, and which is not a possible condition because intersection is always less than probability of B. Hence what? The statement is false. Okay, the statement is false. Okay, this is my wrong statement. Now, what about the second? सेकंड ट्रू है क्या फिर बताओ सेकंड ट्रू होगा अभी सेकंड में देखो इंटरसेक्शन आपका लेस देन इंटरसेक्शन लेस है राइट हियर योर प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी इट इज लेस देन इक्वल्स टू प्रोबेबिलिटी ऑफ ए दैट इज व्हाट that is what 0.3 it is less than equal to 0.8 okay it is less than equal to 0. So the first condition is true. Second one is what probability of A intersection B is less than equal to probability of B, that is 0.3 is also less than what 0.7, that is also true, right? These both conditions are holding. But now if you now try to find out the union by using this, now what is my addition principle? Yes, what is union? It is probability of A plus probability of B minus probability of A intersection B. So what is probability of A? That is 0.8 plus 0.7 minus what? 0.3. And if you find out this answer, it is what? It is what? Yes, it is 0.8 plus what? It is 0.8 plus 0.4 and which is not 0.1. It is 1.2, right? 0.8 plus 0.4 is what? 1.2. This is greater than what? This is greater than 1. Then tell me, it will be true or false. Then this statement will be true or false. This statement is not true. Why it is? Because we have seen the property of the probability. What? Every single probability is always lies between what? Lies between 0 to 1. Probability always lies between 0 to 1. Always remember that. It is not greater than 1. Right? So the second condition is also false. Okay? Second condition will be also false. Okay? Now move towards the next question. That is the last question of our chapter. So the example is, if probability of A is equals to probability of B and this is equals to 1, show that probability of A union B equals to probability of A intersection B equals to 1. Okay, if these two probabilities are equals to 1, then union and intersection will also become 1. How you can show that? Yes. Now, let's go toward the solution. Now we know that the property which we have already seen, that is the intersection, probability of A intersection B is greater than equals to what? It is probability of A plus probability of B minus 1. Right? We know that. Just substitute the value, right? We know probability of A and probability of B. So from this I get probability of A intersection B is greater than equals to what? 1 plus 1 minus 1. That means probability of A intersection B is greater than equals to what? Greater than equals to 1, right? 1 we will get cancelled. But is this possible? Now it will be greater than equals to 1. But is the probability of A intersection B is it greater than 1? It can be greater than 1 or not. It cannot be greater than 1, right? So that means what? It is the possible thing is what? That means what? But what? Probability of A intersection B is less than equals to 1. Right? It is less than equals to 1. Therefore, now if it is greater than equals to 1 and it is not greater than 1, therefore what? What will be my probability of A intersection B there? It will be 1, right? Greater than equal to 1. Greater than or equal. राइट या फिर ग्रेटर से 1 से ग्रेटर है या फिर 1 ही है तो 1 से ग्रेटर तो हो नहीं सकता तो फिर क्या होगा वो इट विल बी इक्वल्स टू 1 ओके द फर्स्ट कंडीशन इज ट्रू राइट नाउ how we can prove that union how we can prove that is union equals to 1 yes just simply use addition principle right so what is the addition principle then yes probability of A union B equals to what it is probability of A plus probability of B minus what? Probability of A intersection B. And probability of A we already know it is 1 plus 1 minus 1. Again this 1 will get answer and I get probability of A union B equals to 1. Okay, what is probability of A union B then? It is also equals to 1. Okay, so this is how we can solve this kind of the problems. Okay, adding all the problems we have solved of this particular chapter that is for theory of the probability. Okay, yes, that means chapter 3 is covered now. The next chapter, I think, conditional probability, will start from tomorrow's lecture. I think tomorrow is the last one lecture. Okay, is the last lecture. Yes, so just wait, I will record.